Okay, everyone, this is part 3 of my Wreath Network. I'm gonna change things up a little bit. We got a little bit of pivoting left to go through. I'm gonna try to take my time and learn as much as I can on that. But as soon as we get to the actual enumerating it and actually pivoting, we're gonna try to go a little faster because we still got a lot left, and we might have a part 4. So let's get started. Yeah. So we left off at chisel, right? If you're curious, I already connected to the network with my OpenVPN in the TryHackme Wreath directory that I created earlier. And actually, let's use our exploit that we had earlier to. Oh no, wait. Let's SSH into the target machine, so we already have that set up, and we don't have to worry about it. So ID say root at 10.8.200. Cool, we're in already. And we are, let's go to the temp directory and let's upload our nmap. Let's grab our nmap. So static binaries. It's in binaries, right? Yeah. Linux CD x8664, right? Yeah, nmap right there. All right, so let's open up Python 3 server. 3 tech m http.server 443. Am I getting that syntax wrong? Yeah, these are all my notes that I've just acquired over time because it's really hard for me to remember all of the syntax. Yeah, Python 3 tech m http.server. Oh, I just used Python. There we go. So we should be able to curl http / what is my IP address up here? At port 443, and we want nmap. Oh wait, you gotta name it, right? Tac O, and then nmap my name. Yep, there we go. Let's ch Let's make it executable. Plus X. Boom, there we go. Let's run a little ping sweep real quick. On no, because we want 10.200.8 dot 2 no, say dot 1 through 255. Save the output. Ping sweep. Attack. There you go. Cannot find emp payloads. So it said cannot find emp payloads. UDP payloads are disabled. Emp scan report for IP. So this host is up. .200.8.100 host is up. .150, .250, .200. Let's try pinging 10.200.8.100. All right, let's do a for I in 1 through 255. And then we're gonna go do ping taxi 1 10.200.8 dot I and then grep for time to live, because you're not going to get a time to live if you don't receive anything back. And then done. All right, so that one's definitely up. Got one. This might take a little bit. All right, what else we got? All right, let's go back. Let's read about some Chisel while that's doing its thing. So, Chisel is an awesome tool which can be used to quickly and easily set up a tunnel proxy and port forward through a compromised system, regardless of whether you have SSH access or not. It's written in Golang and can easily be compiled for any system, with static release binaries for Linux and Windows provided. In many ways, it provides the same functionality as the standard SSH proxying / port forwarding we covered earlier. However, the fact it doesn't require SSH access on the compromised target is a big bonus. Okay. Before we can use Chisel, we need to download appropriate binaries from the tool's GitHub release page. These can then be unzipped using gunzip and executed as normal. You must have an appropriate copy of the Chisel binary on both the attacking machine and the compromised server. Okay. Copy the file to the remote server with your choice of file transfer method. You could use the web server method covered in the previous tasks, or to shake things up a bit, you could use SCP. Yeah, SCP. The chisel binary has two modes, client and server. You can access and help menus for either with the command chisel client server tac help. Cool. We'll be looking at two uses for chisel in this task, a SOCKS proxy and port forwarding. However, chisel is a very versatile tool which can be used in many ways not described here. You are encouraged to read through the help pages for the tool used for this reason. I'm in trouble reading right now. What's going on? Alright. I think I'm a little tired. Long day. Alright. Reverse SOCKS proxy. Let's start by looking at setting up a reverse SOCKS proxy with chisel. This connects back from the compromised server to a listener waiting on our attacking machine. On our own attacking box, we would use a command that looks something like this: chisel server TACP listen port tac reverse background. Okay, this sets up a listener on your chosen listen port. On the compromised host, we would use the following command: chisel client attacking IP listen port r SOCKS background. All right. This command connects back to the waiting listener on our attacking box, completing the proxy as before. We are using the ampersand symbol and to background the process. Yep. And that's the process number 2006. But to find that, because it seems like every time you look at the processes for a Linux machine, they constantly change. So you just grep for, I would just grep for chisel. So like psaux grep chisel, and it should just pop up to find that process if you need to kill it real quick or something. And then all right, so notice that despite connecting back to port 1337 successfully, the actual proxy has been opened on 127.0.0.1 port 1080. As such, we will be using port 1080 when sending data through the proxy. Alright, so here he used the command he talked about earlier, but just filled in the blanks and then backgrounded it. That's the process number. Cool. And then we're connecting from our end with the bottom half, and then it says connected. Or you set ours up first and then his. Okay, yeah, you set up the listener first, so you set up ours and then you would set up his. Alright, notice that despite connecting back to port 1337 successfully, the actual proxy has been opened on 1080. Okay, I just read that. Note the use of r SOCKS in this command. R is prefixed to remotes, arguments that determine what is being forwarded or proxied. In this case, setting up a proxy. Okay. When connecting to a chisel server that has been started in reverse mode, it essentially tells the chisel client that the server anticipates the proxy or port forward to be made at the client side. Starting a proxy on the compromised target, running a client rather than on the attacking machine, running the server. Once again, reading the chisel help pages for more information is recommended. Train again. Alright, let's get through this. I wanna get some command line stuff going. Alright. What are the questions? What command would you use to start a chisel server for a reverse connection on your attacking machine? So that'd be chisel. Let's see. We got it up here. Chisel server TACP, chisel server TACP, listen port tac reverse end. Chisel server TACP. Alright, let's take this hint. Assume the copy of chisel is called chisel and is your current directory. Alright, so let's write it out. Let's write it out because we'll put up a notepad so I can visually see it. So it'd be chisel server TACP port number, which would be 4242 4242 numlock, sorry. And then be tac reverse, right? Let's see. Yeah, there we go. What command would you use to connect back to the server with a SOCKS proxy from a compromised host? Assuming your own IP is that and backgrounding the process. Alright, I like this visual aid with notepad. So it'd be chisel server or listen. LISTN. I think it's listen. Right? No, client. Where'd I get listen from? Oh, that's probably why. No, looks like server. We'll stick with server. Server 172.16.0.200 at port. What was it? What command would you use to connect back to the server with a SOCKS proxy from compromised host? 4242. Nah, I don't know. Chisel client. To use an example, let's assume that our own IP address is compromised. Server's IP is that, and our target is port 22 on 172.16.0.10. That's what it is. All right, so chisel client. Client and our IP address 172.200. So the syntax for forwarding, and this is to from a compromised host. What command would you use to connect back to the server? So that's forwarding. We need (4242) and R. What is that? What is that supposed to be? Man, maybe I should have finished reading this. forward socks proxy. Oh, socks. There it is. It's supposed to be socks. And then background it. All right. How would you forward 172.168.0.100.3306 to your own port 33,060 using a chisel remote port forward, assuming your own IP is 172.168.0.200 and the listening port is 1337. Background this process. All right, so how would you forward to your own port? It should still be client. And then we need our IP address. 172.16.0.100 port 3306. And it would just be the port 1337. And then the IP address. That doesn't really make sense, does it? No, it doesn't. That's what it is. Client. Chisel client, listen IP, listen port, local port, target IP, and target port. This one's a little difficult. I got the ports wrong. So to your own port 33060. So I want my client, my listen IP, and listen port, and this is my listen IP and listen port. So let's do this. Start over. Forgot the client, and then local port would be 1337, right? Remote port forward, assuming your IP. Oh, Jesus, I got that backwards again. So 172.16.200 0 200 to port, and the listening port is 1337. This would still be 360. No, 1337. local port, target IP. I'm gonna mess this up. Three three zero. R3060. So chisel client my IP listening IP listening port to your own port 33060. R133 no. One three three seven. This would be 330. Background. This is probably wrong. Yeah. Oh man. This is a very confusing command. Alright, let's go back and read this. Alright, forward socks proxies. Forward proxies are rarer than reverse proxies for the same reason as reverse shells are more common than blind shells. Generally speaking, egress firewalls handling outbound traffic are less stringent than ingress firewalls, which handle inbound connections. That said, it's still well worth learning how to set up a forward proxy with Chisel. In many ways, the syntax for this is simply reversed from a reverse proxy. Reverse from a reverse proxy. Okay. Chisel server, TACP listen port, TAC socks 5. On our own attacking box, we would then use Chisel client, target IP, listening port, proxy port, socks. In this command, proxy port is the port that will be opened for the proxy. Okay. For example, Chisel client 172.16.0.10, port 8080, and then proxy port 1337 socks. Okay. Would connect to a Chisel server running on port 8080 of 172.160.10. A socks proxy would be open on port 1337 for our attacking machine. Proxy change a reminder. When sending data through either of these proxies, we would need to set the port in our proxy change configuration as Chisel uses a socks 5 proxy. We will also need to change the start of the line from socks 4 to socks 5. Note the above configuration is the reverse socks proxy. As mentioned previously, the proxy opens on port 1080 rather than the specified listening port 1337. If you use proxy chains with a forward proxy, then the port should be set to whichever port you opened. So 1337 in the above example. Now that we've seen how to use Chisel to create a socks proxy, let's take a look at using it to create a port forward with Chisel. A remote port forward is when we connect back from a compromised target to create the forward. For remote port forward on our attacking machine, we use the exact same command as before. Cool. Once again, this sets up Chisel listener for the compromised host to connect back to the command to connect back. Oh man, once again, this sets up a Chisel listener from the compromised host to connect back to. The command to connect back is slightly different this time, however. So chisel client, attacking IP, listening port, R local port, target IP, target port. You may recognize this as being very similar to the SSH reverse port forward method, where we specify the local port to open, the target IP, and the target port, separated by colons. Note the distinction between the listen port and local port. Here, the listen port is the port that we started the chisel server on, and the local port is the port we wish to open on our attacking machine to link with the desired target port. Okay. To use an example, let's assume that our own IP is 172.16.0.20. The compromised server IP is 172.16.0.5. And our target is port 22 on 172.16.0.10. The syntax for forwarding 172.16.0.10.22 back to port 22.22 on our attacking machine would be as follows. Chisel client 172.16.0.20 on 1337, and then R, and this is the port we want to forward back to, and this is the local port we want to connect to. Connecting back to our attacking machine, functioning as a chisel server started with chisel server tech P 1337 tech reverse. This would allow us to access 172.16.10.22 via SSH by navigating to 127.0.0.1.22.22. Okay, that's pretty cool. Local port forwarding. As with SSH, a local port forward is where we connect from our own attacking machine to a chisel server listening on a compromised target. On the compromised target, we set up a chisel server. Cool. We now connect to this from our attacking machine like so. Chisel client, and then listen IP, listen port, local port, target IP, target port. For example, to connect to 172.16.0.5.8000, the compromised host running the chisel server forwarding our local port 2222 to 172.160.10.22, our intended target, we could use chisel client 172.16.0.5.8000, and then our local port 2222, and then our target intended port on 22. As with the background SOCAT process, when we want to destroy our chisel connections, we can use jobs to see a list of background jobs, then kill number to destroy each of the chisel processes. When using chisel on Windows, it's important to remember to upload it with a file extension .exe. Okay. Excuse me. Alright, so now back to this question. I don't know if I'm any better off. Start over. Chisel. Client. Alright. I think this is the command we need right here. So let's kind of do this. Go back down. Paste it right there and fill in our information. Because how would you forward 172.16.0.100 on port 3306 to your own port 33.060? Oh, I think that's where I was getting confused. I thought these were the same port. Okay. So this would be 172.168.0.200 port which one was this in our assume that your own IP is 20. Okay. And we want to forward and our target port on 22. The syntax for forwarding. $200, and then it would be $33. Oh my god. 3306 R, and then the port we want to forward it to 33060, and then the target IP address, which is 172.16.0.100. And that would be port 3306. And then background. Alright. Thank God. I'm so over that question. If you have a chisel server running on port 4444 of 172.168.0.5, how could you create a local port forward opening port 8000 locally and linking to 172.168.0.10 port 80? That is this portion. This is creating connect to this from our attacking machine like so. So that command would look like this. I think. Alright, so we got chisel client 2 so if you have chisel server running on port 4444, this is ours. How would you create? I gotta read this again. Okay. For example, to connect to 172.168.0.5 8000, the compromised host running a chisel server, forwarding our local port 2222 to 172.160.10.22. Remote port forward to use old example. That's the example I just used. It's got to be this one. So let's try this out. Our IP address. And we want to forwarded to port 8000 and linking it to 1080. Wouldn't this be the command? $8,000 and I want to link it to yeah, I want to link it to 80. So it'd be 80 172.16.5 and then 4444. That's not right at all. I think this would be 80. And this is 44. Yeah. Dope. All right. S shuttle. I think that's what this is. This is how it's pronounced. All right. Finally, let's take a look at our last tool of this section, S shuttle. This tool is quite different from the others we have covered so far. It doesn't perform a port forward, and the proxy it creates is nothing like the ones we have already seen. Instead, it uses an SSH connection to create a tunneled proxy that acts like a new interface. In short, it simulates a VPN, allowing us to route our traffic through the proxy without the use of proxy chains or an equivalent. We can just directly connect to devices in the target network as we would normally connect to network devices. As it creates a tunnel through SSH, the secure shell, anything we send through the tunnel is also encrypted, which is a nice bonus. We use S shuttle entirely on our attacking machine in much the same way we would use SSH into a remote server. Okay, so this should be a lot easier, hopefully. Whilst this sounds like an incredible upgrade, it's not without its drawbacks. For a start, S shuttle only works on Linux targets. It also requires access to a compromised server via SSH and Python. And Python also needs to be installed on the server. That said, with SSH access, it could theoretically be possible to upload a static copy of Python and work with that. These restrictions do somewhat limit the use of S shuttle. However, when it is an option, it tends to be superb. All right, so I know on our attacking machine, oh, whoops. Or our compromised host. Oh, look, we found actually the hosts that are up. That's cool. That's good for later. We got 10208 and 10208 200, 10208 250. So, and 1.1, which is probably just like the default gateway of this network. Yeah, but all right, cool. So we got 3 up. So we do have Python, and this is a Linux box. So if the other boxes in this should be Windows, so these guys should be Windows machines that we're going to be pivoting around. So if our initial foothold is on a Linux machine, we should be able to use S shuttle, since it's superb, right? To connect to our compromised server, Linux server we got root, then from there to all Windows, hopefully. See if that works. But yeah, let's start a port scan for these guys. So we'll do kind of like the same thing. Ooh, does this have netcat? No netcat. Let's see if we can upload netcat real quick. Am I still... Okay, I'm still hosting the server. Is netcat in here? No. Let's upload netcat so we can just connect. It'll be really easy. We could write it in Python, but that'll take a little bit. I don't remember exactly How? I think it was in. Whoops. Where is netcat? See binaries. Let's just do x86. No. x86 underscore. How is netcat not in here? Alright. I guess we can write it in Python real quick. Since well, let's try nmap first. See if it'll work. Nmap tac. We'll do TAC-PN because a lot of Windows networks don't respond to pings. And then we'll do it had us do the first 15,000 ports when we first started, so we'll do that again. TAC-P 15,000 on. We'll do 10,200, 8,200. I'm gonna take a screenshot of this real quick, actually. And put in my notes. TryHackme Wreath screen caps. See if this works. Okay, that was fast. Oh, I had to put a range. I was only scan one port. Okay. Alright, I'm getting ahead of myself, though. We still haven't finished the teaching portion. Alright. This one's taking a little longer. Alright, let's let that run and go back. I'm not even gonna look at the ports yet. We need to learn this first. It's the last one. Alright, we left off at superb bet. Alright. First of all, we need to install S-Shuttle on Kali. This is easy as using the app package manager. Sudo apt install S-Shuttle. Let's do that. Sudo apt install S-Shuttle. Failed. Let's close this guy. The following packages are automatically installed and no longer required. So do I have it? It says it was installed. Following new packages will be installed. Upgrade 0, 1 newly installed, 0 to remove. After its operation, additional disk space will be used. let's go to the GitHub and get cloned from there. github.com shuttle. See if that pops up. Poor man's VPN. Oh, let's try apt-get install. I just did sudo apt. No, didn't like that either. Debian stretcher later. Alright. Alright, let's do this. Let's clone it and follow these steps. And we're going to go cd into the repository shuttle and run the setup.py install script. Oh man. let's move that to and that. So that would be binaries, stack binaries. I'm gonna do absolute path. CTF. Oh man. Press the wrong button. CTF. TryHackme Wreath. shuttle. To CTF TryHackme Wreath. It's right there. What do you mean there's nothing? There's doesn't, whatever. You know, we're just gonna SS shuttle. I could just do that. To CTF TryHackme Wreath. There we go. All right, now let's do this. CD SH shuttle. Let's run that. Py.py setup.py. There it is. Yeah, I probably. Warning, the pip package is not available. Falling back to easy install for handling setup requirements, test requirements. This is deprecated and will be removed in future versions. Line 71. SSH VPN. Runtime support support for Python 3.6 has been removed. And setup tools. So line 31 in SCM version, use SCM version. So pip install SCM version. That's not a thing, is it? What is wrong? Do I have to upgrade my Python? Update Python version. Update new Python Linux. How to upgrade to Python. Windows, Mac. Refresh. All right. Not Windows. Oh shit. All right. Python 3 version. I have 3.9.2. I think that's the latest version. Linux, here we go. Sudo apt update, sudo apt install Python 3.9. Sudo update alternatives, tech install. What is the latest Python version? Three 3.9.6. So update to Python 3.9.6. Okay, now I need to know how to update. I have a feeling this path that they're listing is not the path where my Python is. Well, you know, we'll try it out. Sudo update alternatives. Next, type the following command to configure the priority status of the versions. Sudo update alternatives, config 3. The output displays the available choices and their assigned number. In the example below, the numbers are 0, 1, 2. Type the number of the version you wish to use and press enter. I'm using 3.9. Alright, so let's try this. Sudo update. User bin Python 3. Old versions 1. First, add the old version to the list with the command. I didn't find anything on that one. Looks like this one. This is our guy right here. 443 3306. Is that? That's MySQL. Hostmon. Man, why is this not working? It's in front of my face. I just not. Support for Python 3.6 has been removed. I don't have Python 3.6. Warning, the pip package is not available. Which pip package? Alright, let's look at the code. Subroll setup.py. Update available. No, that's from setup tools, import setup, find packages. Okay. Setup config. So it's subroll setup.cfg. PyTest. Tool. Where is the package? Maybe I should be in this one. No. Now add new versions. What package am I missing now? Let's try it again. No, not that. Line 60, line 31. Setup tools. All this is messed up. So, setup. Does this give us the most latest? The latest. Maybe I'm in the wrong area. Probably not. This sucks. This looks like the same shit I was on. Your client machine or router is Linux, FreeBSD, or Mac OS. You have access to remote network via SSH. You don't necessarily have admin access on the remote network. The remote network has no VPN or only stupid/complex VPN protocols. Or maybe you are the admin. It's also possible to install a virtual environment as a non-root user. Let's see if I can get it on the machine. Is there Git on this? Let's take a picture of this real quick. We stall on this guy. It's got git. See if we can stall in this. Probably not. I don't see it. Oh wait, I am root. Apt git install s shuttle. Apt command not found. So like yum. Guess it is. Yeah, that's not gonna work. I don't know why I tried that. It's not connected to the actual internet. This is really bothering me. This is really bothering me. Alright, let's see. Let's copy that, throw it into Google. Setup tools is removing easily. Deprecate warning. Let's see what we got. Refer to that. Build out still calling out to setup tools.command.easy install in. So what our take and future direction on this? Mark the easy install script and setup tools command as deprecated, and use pip when available to fetch build wheels for missing setup require / test requirements with the following differences in behavior. For now it seems to still work though. I tried with Python 3.7.4 and this requirements.txt. Said it solved it. Failed to fetch. Fix tech missing. I might stop the stream for a little bit and figure this out. If this doesn't work. Oh, there we go. Awesome. Oh no. I'm gonna sudo remove s shuttle. Whoops. Cool. Alright, that would figure it out. Took a little longer than I wanted it to, but we got it. Okay, so first we need to install a shuttle on Kali. This is easy. Got it, did it. Wasn't that easy for me. The base command for connecting to a server with sshuttle is as follows: sshuttle tech r username at address subnet. Okay, yeah, it's like a SSH. For example, our fictional 172.16.0 whatever network with a compromised server at 172.16.0.5. The command may look something like this: sshuttle tech r user at 172.16.0.5, and then our subnet 172.16.0.0/24. Okay. We would then be asked for the user's password, and the proxy would be established. The tool will then just sit passively in the background and forward relevant traffic into the target network. Bear in mind that this may not always be successful though. As with the previous tools, these commands could also be backgrounded by applying the ampersand symbol or and symbol to the end. If this has worked, you should see the following line: connect to server. Cool. Well, that's great, but what happens if we don't have the server's password, the user's password, or the server only accept key-based authentication? Fortunately, sshuttle doesn't currently seem to have a shorthand for specifying a private key to authenticate to the server with. That said, we can easily bypass this limitation using the SSH tech command switch. Yeah, this switch allows us to specify the command, what command gets executed by sshuttle when trying to authenticate with the compromised server. By default, this is simply SSH with no arguments. With the SSH tech CMD switch, we can pick a different command to execute for authentication. Say SSH tech I, so interact with the RSA key. So when using key-based authentication, the final command looks something like this: sshuttle tech r user address. Basically do another SSH, give them the key file, and then the subnet. Subnet is always last, it looks like. To use our example from before, cool, it just filled it out for us. Please note, when using sshuttle, you may encounter an error that looks like this: client connected, client loop, send disconnect, broken pipe, client fatal. Got it. This can occur when the compromised machine you're connected to is part of the subnet you're attempting to gain access to. For instance, if we were connecting to 172.16.0.5 and trying to forward 172.16.0.0.24 subnet, then we would be including the compromised server inside the newly forwarded subnet, thus disrupting the connection and causing the tool to die. To get around this, we tell shuttle to exclude the compromised server from the subnet range using the TAC-X switch. To use our early example, shuttle TAC-R, and then the TAC-X switch is right there. So exclude the subnet. This will allow shuttle to create a connection without disrupting itself. Okay. How would you use shuttle to connect to 172.16.20.7 with a username of pwned and a subnet of 172.16.00.16? So it would be shuttle TAC-R username pwned at 172.16.20.7 and a subnet of that. And then just the subnet would be 172.16.0.0/16. Cool. What switch and argument would you use to tell shuttle to use a key file called privkey located in the current directory? Wouldn't it just be SSH command? I think it wants that right here. So privkey should be right here. Just want this, like tac SSH tac cmd, and then SSH tac I privkey. Okay, so that's all I wanted. You are trying to use shuttle to connect to 172.16.0.100. You want to forward the 172.16.0.x/24 subnet range of IP addresses, but you are getting a broken pipe error. What switch and argument could you use to fix this error? Man, that's the TAC-X. 172.16.0.0/24. No, it is the dash. TAC-X 2.16.0.100. There we go. Ooh, finally. Finally, it's done. Alright, so there's a note here. If using SOCAT or any other technique that open up a port on the compromised host in the course of this network, please make sure to use a port above 15,000 for the sake of other users in earlier sections of this course. Okay. Alright, here we go. I'm gonna call. Hello? Hello? Yeah. Okay. Alright, I'm gonna put a pause right here I'm gonna go eat dinner and I'll be right back. So I'll see you in a little bit.